In order to take best advantage of the Quickie IRIS's rotation in space design, you must understand how to make three different independent adjustments. First, the CG-CR adjustment. Second, the front stability adjustment. And third, the rear stability adjustment. First, let's discuss the adjustment of center of gravity and center of rotation. In this example, the tilt mechanisms have been disabled, so the system is free to rotate. We will also maintain the seating setup. The position of the backrest relative to the footrest will not change. In the first example, the center of gravity is behind the center of rotation. As a result, when support is left on the chair, it falls automatically into the most tilted or rotated position. In the next example, center of gravity will be in front of center of rotation. In this example, the chair will fall into the most upright position. But when the center of rotation and the center of gravity are properly aligned, the system can be left in any position with the pins disengaged and will be stable and not subject to rotation. So here we have an example of the center of gravity behind the center of rotation, and as you've seen, this will cause the system to fall into a tilted position. But by moving the back canes and the leg rest hanger assemblies an equal distance, you can change the relationship of CG and CR to bring them into alignment. The CG forward to the CR, or center of rotation, simply pull the two screws that hold the hanger assembly in place in the seat rail. Move it forward the desired distance and reinsert the fasteners. In the rear, pull the fasteners that hold the back cane assembly in position on the seat rail and move it forward the same distance. The seat depth has been maintained, the distance between the back canes and the footrests, but the entire seating system has been moved along the seat rail forward to align the CG and CR. Now let's look at front stability. The front stability adjustment allows you to reposition the carriage over the base frame. In the previous example, you'll remember that we moved the person's center of gravity forward to match the CR. This also moved it forward relative to the caster wheels. Now, as the system is put into a slope, you'll notice a point where the CG goes forward of the position of the front caster wheel. This is the point of instability. We can make a simple adjustment by moving the carriage rearward and realigning the hanger and the front caster. This will improve the front stability significantly by changing the slope. The last adjustment capability is rear stability adjustment. This is accomplished by moving the rear wheel forward and backwards on the base frame. In this example, the center of gravity passes over the point of support, the axle of the rear wheel, at approximately 14 degrees. By simply moving the rear wheel rearward on the base frame, you can significantly and easily improve the rear stability.